Hello, my name is Ike and I'm studying a Master's of Science in Aeronautical Engineering here in Glyndwr University, and today I'm going to talk to you about my project, which is the numerical investigation of the fuselage surface morphology using computational fluid dynamics, CFD. There are too many aircraft flying nowadays on the skies, and it's very important to reduce the carbon emissions. That's why I'm using the principle of a golf ball with the impulse on it to implement that on the fuselage of an aircraft to reduce the drag and hence lower the CO2 emissions. So the first stage of my project was created an scale fuselage of an Airbus A320. That's the model I used, and for that I used Ikeya V5. Once that model was created, I exported a file, a STL file, to use the Glyndwr University 3D printer and came up with a model, a scale model, in order to test as well this on the Glyndwr University wind tunnel to get results and see the experimental part of the project. The second stage of the project is getting that 3D model printed on the 3D printer and tested on the wind tunnel. It will be tested at different angle of attacks and different speeds, and what we're measuring is the lift and drag of the fuselage on the wind tunnel in order to be able to correlate the data that we get from here with the CFD simulations made in ANSYS 15. This is the third and the last stage of the project, which is creating a numerical model to analyze the behavior of the flow if we implement those shapes like triangles, hexagons, dimples on the surface morphology of the aircraft. Those simulations will be analyzed with ANSYS 16 here in E1 and Glyndwr University, where parallel simulations can be undertaken. And these results then will be compared with the ones obtained from the wind tunnel, the experimental ones, and see if they correlate and see if those dimples in the end with different shapes, depth and pattern, they have any influence on the total drag of the aircraft, if we are able to reduce drag by implementing those dimples on the fuselage. The outcome of my research is to further reduce the CO2 emissions of an aircraft when it's flying. Because of all the aircraft flying nowadays, it is very important to reduce as much as possible the CO2 emissions. That's what all manufacturers they're looking for, to come up with a more efficient aircraft every day. This project, this research works in that direction. I expect this, by implementing this impulse on the fuselage, on the surface of the fuselage, that will help to produce less CO2 emissions, and this is what all manufacturers they're looking for. I chose Glyndwr University to continue my studies in aeronautical engineering because I like the masters, the program, and also because all of the facilities that the university provide, not only the computers to run the simulations, but the wind tunnel, the 3D printer to first build the model, and then the flight simulator, for instance, to see the behavior and hands-on on what really is. So I couldn't think in a better place now to do the masters, in my case in aeronautical engineering.